At this section, we're gonna move on to libraries for asset and data representation. So I'm gonna ask you guys, while I'm kind of saying this, everyone can get up their laptops. We're gonna do an interactive notebook right after this. So first, some essential Python libraries that you're gonna need to know are NumPy, pretty much like Lauren was talking about going into linear algebra. This is pretty much a Python library where you can use different mathematical operations and kind of use those and transform like different matrices, like in linear algebra. And you can just do different math operations for arrays, right? It's just basically mathematical arrays. Pandas is pretty much putting your data in a data frame and being able to analyze it in a time series manner. That's how it applies to finance. And matplotlib is pretty much making graphs and visualization using Python. Stats models, that's more of your descriptive statistics. And if you want to run simulations, scikit-learn, that's your machine learning library. And we're going to use Yahoo Finance, which is Y Finance. It's pretty much API library. So it connects to Yahoo Finance's database, and you're able to get all those prices out from the database and import it into Python, right? And so you can connect that with a Pandas data frame. Okay, wait. So yeah, so at this time, if you go to your Notion and go to lectures on traders at SMU Alpha and click on the Jupyter file, that's posted right there. Let me know if you guys have any trouble getting to that. Make sure to download it, run it in your environment. So I'm just gonna come around and try to people. So click the three dots, download it, and then go to your Jupyter lab. We got in trouble.
I think I'm like, I downloaded it. Oh. Yeah.
Yeah. All right, I'm gonna go ahead and start. Do most of you have it up? Yeah. Okay.
Is it Jupyter Notebook or Jupyter Lab?
It's go to Jupyter Lab and then you can import it from there. And then look at the screen when you're done, so I know that you guys are ready. Okay, are we all good? No? We're all waiting on you, Mateo.
Okay, bro. Well, chill.
What are you struggling with?
I just got in, I'm working on it. Wait, where is it again? Sorry.
All right.
It's in Notion.
It's in Notion. Okay, I'm gonna go ahead and start. So, right, libraries we're gonna cover Yahoo Finance, Pandas, NumPy, Matplotlib. Lawrence, do you want to help me?
Yeah, if you gotta find. He's telling me.
Okay, so pretty much for Yahoo Finance and Pandas, we can combine both of these libraries to basically import Apple prices from Yahoo Finance and put it in a data frame in pandas. So to do that, you can see a structure for importing a model. You import the model name and as an alias, like an acronym. So if I wanted to import Yahoo Finance, I would say import Y Finance as YF, right? And then I'd return that because we also need our pandas package, right? We need to put that Yahoo Finance data into a data frame so we can analyze it. So we say import pandas as PD, right? So whenever you reference pandas or Yahoo Finance, we can reference it as YF and PD. So to now fetch historical Apple stock data from the year 2000 to today and put it into a data frame so we can represent it in Python. We can do to create a data frame. We do DF. So data frame stands for DF. You can see right here in the comment equals YF. Remember, we're referencing the Yahoo Finance download. We put the ticker Apple, right? Comma for a different argument inside of the function. Start equals 2000. And by the way, this is all on the assumption that you guys have these downloaded, which was in your first assignment, I believe, right? Okay. 01, 01. So from January 1st. And then we're setting the ending prices to 2025, 03, and then 09. And then we're going to put the interval for one day. And then we're going to close it with a parenthesis. Okay, so I have to run this cell first. That was my mistake. And it says the data frame is loaded. And the data frame basically has gathered all the data from Yahoo Finance of Apple, starting from year 2000 to 2025 in 1 day intervals. Did everyone run that and get an okay execution? Yeah.
It says YF is not defined.
Did you
Is that
import?
because, what's up?
Did you run the cell
Yeah,
first?
mine looks exactly like yours.
But did you run it
Yeah.
and you haven't?
Load Yahoo Finance. Maybe not Yahoo Finance. I think I did that. I don't know, maybe not.
Okay, well, check if you downloaded it or not, or like honestly, like you might just have to look at try going to your terminal and say pip install
Okay,
Y Finance, or if not, you just might have to follow along with Will.
okay.
Okay, so now that we have our data frame, right, in pandas, we can basically represent this using different methods that pandas has. And pretty much we can start by using a dot head function in pandas, right? So our dot head function is going to print out the first 5 rows of our data frame. So this is good to get insight on how our data is going to look like and how our data set is going to look like. So if we do df, right, we named our data frame df, and we do df.head, it's going to print out the first 5 rows. And so these are actually the first 5 trading days in the year 2000 for Apple. And you can see it's closed, high, low, open, volume. Right? And so if we wanted to get all the trading days, right, we can use the dot shape function. So you can see the structure of it right here. We can do df.shape. And by structure, I mean rows, meaning how many trading days, and columns, how many features of the stock price we're getting. So if I do df.shape, okay, so some methods don't have parentheses. So you do df.shape without parentheses. So it'd be 6,333 trading days and 5 columns, right? Those 5 columns are close, high, low, open, and volume. So if we want to get the most recent prices because we're starting from 2000, then we use df.tail because that would give us our last 5 rows. Mateo?
I was gonna ask, like, why did mine work with the parentheses used it?
For shape?
Yeah.
I must have a different version of pandas installed, but it's really not a big deal, to be honest with you. So you do df.tail, try with parentheses, and you get the last and the most recent Apple prices. And you can see a difference in between those closes from using df.tail and df.head, because we get our beginning prices, which was like 80 cents a share, and now we get $238 a share, right? And if you want to get df.columns, you can get all the features that the data frame has. So all the columns pretty much. So yeah, this one doesn't have parentheses. we get our close, high, low, open, and volume of apple, right? And so another method in pandas is the describe method. A describe method pretty much gives you descriptive statistics such as the count, mean, standard deviation, 20%, 25% quartile, and other whisker plot dimensions or statistics. So if we do df.describe, we can basically get how many trading days there is, the mean of Apple stock price, the standard deviation, and the max, right? Has everyone tried it? Is it good? Okay, I'm gonna move on. Columns, right? We can create a new data frame. Let's call this one closing df, just like a variable. Then we could reference our old data frame using df, and our columns are represented. This closing df, we run that. It basically gets us only our closing prices, right? In a new column. And so if I only want to get certain pandas methods, we can use a .lock and .ilock method. So right here, this is supposed to say .ilock. I don't know why it's not. Little error for me. .lock and .ilock. So .lock is used to select rows and index number or position. So let's print out the trading information for the first 10 days. How do we think we do this based on position or name? I'm asking you guys. I do, sorry, erase that. df first 10 equals df.ilock. Right? So we want to get the first 10, right? So we don't write anything, we write a colon, and then we do an ending of 10. So this is your ending, and right here in like where nothing is written, that's your start amount. And your colon is basically the range of that. So if I print that, I basically get the first 10 Apple prices or trading days. Right? And an example of lock is, let's say I only want to get prices from 2019, right? I can do df 2019 equals df df underscore 2019 because it's our new data frame. So I only get or sorry, I typed it in 2020. So I only get trading days from 2019. Is that pretty straightforward?
How do we know what these names are before? Like, could we ever get a data set that's like weird names for years or anything like that?
Yeah, so you pretty much just type in any value, any string name inside any row, and it'll get you that one row with that one name. It's similar to Excel. I don't know if you guys have taken done Excel, but it's pretty much like, I know there's a function that gives you like the row with any like argument or any cell in it,
Okay. Yeah.
right? Like VLOOKUP or something. It's like the same thing.
Okay.
So we can actually compute Apple price changes using NumPy. So NumPy uses mathematical arrays to perform function on its data similar to linear algebra. First, we have to import NumPy, right? Import NumPy as MP. So MP is this acronym for NumPy, right? And second, we want to convert our Apple closing prices data frame / column to a NumPy array to perform mathematical operations on it, right? So we get our closing prices. That was the array we created just for closing prices equals df close. Sorry. Dot values. And we can use this using a dot values method. This basically turns a data frame into a mathematical array in NumPy. So after that, we can get closing prices, which is our array, and we closing prices. And we closing prices, which is our array, 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 and we closing pri dot flatten. This is basically flattening it to a 1D array, right? So earlier, sorry,
When like doing single quote versus double quote doesn't change it.
No.
Like when the string.
but I would prefer single quote. But yeah, just for data consistency. But yeah, so now we want to get it into a one-dimensional array because we're only analyzing closing prices. We don't care about date anymore, just to make it more simple, right? So instead of rows and columns, we're just using rows, right? So this is going to flatten the data. So to show your array flattened, we're going to print this, right? So when we print it, we just get a 1D array of all the prices, right? So this is a very big 1D array of just one row, right? So using this array in NumPy operations, you can compute the historical daily price returns. So we can get the percent change from the last day to the new day, right? So the structure of the equation is np.diff, which is a NumPy function, and you insert basically the price list or the price array, and you divided that by the price of the most last day, which is using -1. Or sorry, you divide it by all prices except the most recent one, which is -1 index. So if I run this, it's basically daily returns equals np.diff. So our np.diff basically gets the difference between consecutive indexes, right? So we can get the daily change from every day consecutively, right? Because since we want our daily change. Divided by closing prices, bracket, colon, remember indexing, and then -1. So if we print daily returns, we basically get the percent or the proportion change from every day, right? So now we can use these daily returns to calculate rolling 30-day mean, rolling 30-day median, and rolling 30-day standard deviation. But I think for time purposes, we're just gonna do mean and standard deviation, right? So pretty much, well, I'm gonna go over the directions first, and then we're gonna do it. So first, we're gonna have to multiply daily returns by 100 to get in a percentage form, right? Second, we store the daily returns in a data frame using the structure below. So we basically turn in percentage form. We have our NumPy array in a percentage form, and then we need to put it back into a data frame to create a data frame, right? And so we add 3 columns. We add 2 columns of our rolling 30-day mean and our rolling 30-day standard deviation by calculating each using NumPy functions. And basically, a rolling 30-day mean and rolling day 30-day standard deviation is the mean and standard deviation that is weighted throughout 30 days. So basically your monthly mean, right? So every day is added into the mean. Every day is added into the standard deviation. Does that make sense? Yeah, can I just get some nods at least? But yeah, so then we can use a panda.tail method to return our data set and see how it looks, okay? So putting all the steps together, we can do this. Daily returns equals daily returns times 100, right? So that'll multiply times 100, giving us a percentage form. Returns df, so we're making a data frame right now, equals pd.dataframe. And the pd.dataframe, with your arguments assigned, basically makes a data frame from the information you provided, right? So right here, we're going to put curly brackets, no curly brackets to put text in it, right? To label our columns. So we're going to put parenthesis, curly bracket, quotation mark, daily return, parentheses, percentage. Daily return, quotation mark, colon. This is going to be a bit confusing. This is more memory based, to be honest with you. Returns, dot, round, 2, and curly bracket. Then index, I'm going to break it down at the end. Index equals df dot index. Okay, so basically we first have our column name, right? And then we have our column, our row values, right? So we're basically daily returns rounded to 2 decimals. And then we're indexing pretty much, an index is like what we keep track of our values with, like 0, 1, 2. You remember how Python 0 index? We're setting that index to our original data frame, which is a time index. So we're setting all those values corresponding to time instead of just straight integer numbers like 0, 1, 2, right? So once that data frame is created, we can now therefore add columns and calculations to that data frame. So basically we do that returns via 30-day mean percentage equals returns df daily return okay. Yeah, so don't make that mistake. Make sure to have your quotation marks in the right area. And you want to have the original name of your column to reference it. So like this would be the same as this, right? Dot rolling window equals 30 for 30 days. And then you do your dot mean function to get that. Okay, does everyone see that? So this can be a bit complicated syntax wise. I'm going to break it down, but before I break it down, just for time purposes, I'm going to change this to standard deviation. Right, so it's pretty much the same structure. Off our return arrays right here, which is right here. This would be your rows, right? And then this is going to be your column, right? So you're basically creating one column in all these rows, right? And you're using the index of your original data frame, which is your time, right? So it's going to go by year, right? Instead of 0, 1, 2, 3, 4, 5, 6, like a normal Python list would, right? And then right here, I'm adding a column into that data frame. Notice how this data frame is created. And then right here, I'm calling it on the standard deviation function. So this is one of those things right here that's going to take more practice with pandas that I'm going to assign in the home. DF, right? Pretty much the price changes for each month, right? Did everyone get that? Okay.
Wait, why do we have NAN there? Like, what does that mean?
NAN, that's an error. So pretty much you see how it's 04?
Because there's no previous data. Right?
Bingo. There's no previous data.
Oh, so it's a 30-day window.
Yeah.
So
And
you would
then
start seeing data on day 31.
Right? So pretty much, these are all the functions. You can take a look at them, but we're only going to use a bit because you don't need to use all of these to create a graph. And you don't need to put all these arguments in the functions because it's just going to give you the default option, right? So to do this, we have to import matplotlib. It says it right there in to be able to use its functions, right? This is a library and we can use its functions like we discussed in our first session about Python. So then to draw a figure, we can do plt.figure. This pretty much sets out the dimensions of the graph. Then we can do plt. Prices because we just want to plot closing prices. And then we could just close that, right? so if you go back to what the function argumentation is, you need your X and your Y. So the X is serving as our index, like our dates, right? And the Y is our closing prices. So pretty much after that, we can assign a title. We can say PLT title is Apple stock price, right? And we could also assign titles for X and Y axis. So PLT.X label equals or is date. PLT.Y label is price, right? And then we could do PLT dot show to show this graph. Okay. Okay, so look, if you guys should have ran that correctly, you should have gotten this. Just take a look at the syntax. Yeah,
Is there a reason why you use double quotes on the Apple stock price, date and price?
yeah, because that's pretty much for your title.
Would it matter if you did single quotes?
See? It wouldn't matter.
Okay.
Yeah. Move on.
Like 12 and 6, what are those? Like
Those are dimensions, so that's the length,
They're like what's with the.
huh? Yeah, it's like pixels. All right. Isn't that pretty cool? You guys would say? Yeah.
Scroll up a little bit. Why didn't you put spaces around that equal sign?
Equal sign?
Yeah, but you did in previous examples.
Like this?
Does it matter or no?
No, it doesn't.
Oh, okay.
It's Python isn't really that space sensitive.
Okay.
Okay. Do you guys want to do one more applying the standard deviation? Just more of a practice? Yeah, let's do it. That's what I like to hear. Everyone hates Mateo now. Yeah, so we're gonna do the same thing, pretty much setting the figure size to 12 and 6. And then we're gonna do plt.plot to set the X and Y dimensions, right? So we're gonna do returns, df.index.
Do you mean it's that plot?
Sorry, yeah. I'm having to like switch between screens, so. And then returns, df, 30-day. Now what we can do, we can scroll up and we can simply just copy this, right? From here. And then we can close that. And then plt.title, Apple return 30-day standard deviation. And then we can do plt.x label, saying our date, plt.y label, saying our standard deviation. Right, and then we could even add in a grid. We can say plt.grid, saying true. So we could add grids, and then we could do plt.show to show it. Did everyone plot it out? So what's actually super cool about this is like having the standard deviation for a stock price and visualizing it using tools like this can actually give you insight into like global like economic events. Like if you take a look at the standard deviation at 2020, I mean, what happened in 2020? Can someone tell me why that standard deviation might have spiked? COVID, right? Take a look right after 2008, right? What happened? Exactly. And can anyone, this is more of a tricky question, but can anyone tell me why? Sorry?
9/11.
No. Why around this area it spiked? Yeah. Correct. So I would say like this is a very useful tool to see like macroeconomic events. Move on.
In the plt.plot,
Yeah.
the first one of the comments can give your x axis and the after comment your y axis.
No, you X and Y first. Is that what you're saying?
like before the comma is X and then after the comma is Y.
Yeah,
Okay, and then it turns and just like you have to index.
Yeah.
Gives you the date.
yeah, it gives you the date. So it's usually your daytime index. So I'm gonna basically say some quick announcements. I have a homework. Sorry, I know you guys want to enjoy your spring break, so you guys are gonna be so bored. So like, I'm basically and no, this will actually be pretty cool, like in my opinion. Like I think if you guys like what you just did, you guys will find this interesting. So it's pretty much using different libraries like NumPy, Pandas, and Matplotlib to pretty much like plot out and do a Jupyter notebook on the Dow Jones Industrial Average. And using that, like I pretty much want you guys to like do like a little report saying like, okay, like what economics events happen. That pretty much like represent different layoffs, any sell-offs in price, or just any macro events. And write a like one pager and then just like submit a 3-minute video. It's not that hard. It could take you like an hour or two if you just put your mind to it. And I'm gonna kind of lay out the Jupyter notebook via email in the next 2 days in Notion, and everything will be there. I'm just trying to put a lot of like care into the project to make sure it's impactful. Well,
Is this due March 19th or?
yeah, it's due by next session, so whatever next session is.
Next session.
25th.
25th.
26th.
Yeah, and I also want to hit on new upcoming homework policy in GitHub. We're creating a system to kind of just like make sure have grading done and have like completion. And so when that system is in place, we're gonna send out like an email, kind of giving you guys like a 5-day grace period. But we like expect like no missing assignments. To be honest, like we're putting forth a lot of effort into creating all these assignments. Like the least everyone could do would actually like complete them. So we're gonna stop having like tolerance for like any of that. I guess like after like the instructions are laid out, and I'm gonna make a video on how to submit everything. But I'm gonna give you guys like a 5-day grace period. Well.
So I just want to make this really clear. You said next session we meet.
Yeah.
So we have 2 weeks to do this mini project.
Yeah.
25th.